Commercial aviation operates largely using commercial transport aircraft. They use fossil-derived kerosene, which is not a renewable resource.
When it's burned in the engines, it produces carbon dioxide that contributes to climate change, but it also emits nitrogen oxides, water vapor. We're more concerned with the overall global impacts from commercial aircraft because they are emitting at altitude.
At its peak, commercial aviation produced over 1 billion metric tons of CO2. Transport class aircraft that we fly contribute about 93% of jet fuel utilization. And that full utilization is somewhere on the ballpark of about 100 billion gallons of jet fuel every year. What we're seeking to do in the new Center for Sustainable Aviation is a handful of things. The first is really to tackle the most ambitious problems that challenge our aviation field today, which is sustainability. Solutions we introduce have to be economically viable. Solutions that we produce also need to meet a social sustainability aspect that promote the well-being of populations who interact with the aviation ecosystem. There are many different people looking to develop these groundbreaking technologies in order to foster electrified aircraft systems. And a lot of people right now are looking at other energy carriers, such as things like hydrogen, for instance.
We are in the middle of another revolution in aviation. Electrification, for example, has opened up the design space. Electric power is a lot easier to distribute and control. You can design the aircraft in fancy new ways.
When you think about aviation, really the critical elements in a battery are that you have the power that you need, for example, takeoff. You have the energy density for the range, and of course safety is very critical in any aviation environment.
The energy density of jet fuel is about 50 times higher than the best batteries out there.
In an aviation where you both have limited space, you want to maximize cargo, you want to maximize passengers, you want batteries that don't take up a lot of space. And the second is, in the aviation environment, weight is very expensive to carry. It requires a lot of energy. So you want the battery to be relatively light for the amount of energy it carries.
So sustainable aviation fuel uses plants or algae and then chemistry to make the fuel. And as a result, the carbon dioxide is carbon that was pulled out of the atmosphere, and you're just putting it back into the atmosphere. So it doesn't really count as climate change.
The aviation sector is very safety oriented. So the process for actually certifying a new biofuel or alternatively derived fuel is pretty long, and it goes through various phases. But essentially they just look at whether or not the fuel looks like, behaves like conventional petroleum derived kerosene. Jet fuel testing happens in lots of different settings. Getting all the data in one place is really good for kind of like providing that scientific evidence to show that these fuels can actually be very similar to conventional fuels.
We are also working to promote the education of future leaders in this area. A lot of the things that we're starting today, we're not going to be able to finish. And so the onus will be upon us to raise the leaders, the future thought leaders, the future engineers, the future politicians, the future people who are going to be contributing into this field for generations to come.
This is a very exciting time for someone to enter this field. The design space has been opened up. You're not limited by a lot of the constraints you used to have in the past.
I think the adoption for electric aviation is going to be faster than many people think. That it'll be much like electric vehicles. The first 10 years is a slow rise, and then you see a very dramatic rise after that.
I think what we're going to continue to see is probably an increasing diversity in the sourcing of the feedstocks and the production types for these different sustainable aviation fuels.
These mega trends of replacing carbon as a fuel to using electricity as a fuel, is only going to accelerate.
We really need to plant the flag and not to promote ourselves, but to rally the entire field together to build the better future that we need.